Ngayon naman, doon naman tayo sa index of discrimination. Since itong ating mga items ay dichotomous, so ang gagawin natin, i-correlate lang natin per item, no, yung dichotomous data dito sa ratio data na kanilang score. So ang gagawin lang naman natin dito ay correlation. So correl, and then the first array is this one. So 1, baba, hanggang ika-50 yet student. Hanggang dyan na nga sa 50, and then close it. And then the next array, kama lang. And then the next array, yung isang value na iyong ko-correlate ay yung score ng bata. So, ilan natin siya pababa. And then, close natin. And that's it. We have 0.35. Round lang natin. And then we already have the index of discrimination for letter D. Lagyan lang natin ng $sign para hindi siya umalis doon sa column niya kapag ating kinopya. Yan. 0.36, so yung sunod ay 0.59, and so on. Yan. So ngayon, tingnan natin kung paano yan i-interpretin. So balik tayo doon sa index of discrimination at i-check natin kung paano siya i-interpret. So yung 0.36, so it's a good item. Good. So yan yung ating evaluation. Sabihin, it can discriminate, no, between the better students from the poor students. 0.59, oh, this is satisfactory. And then 0.33, it's a good item. 0.57, very satisfactory. 0.32, good item. Okay, very satisfactory, 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 satisfactory. So I guess the item in this test really discriminate between the better students as compared to the poor ones. So actually, this data have been sampled from the achievement test that I developed, but it's around 30 plus items, and sampled also from 100 plus students, pero 50 lang yung aking kinuha. So maganda itong ating test. Kaya tingnan natin, parang wala tayong matatanggal dyan na item if we were to discriminate. Okay, so ngayon, i-compute natin yung reliability, yung Cronbach's alpha na sinasabi. Kopyahin natin yung ating matrix. Pag nang siguro pwedeng kopyahin din si heading. Tingnan natin, mag-eksperimento tayo. Tapos, hanggang dyan lang sa number 50. And then we copy that. And then we open our SPSS. And then we paste it. Pero yung ating ilalagay ay paste with variable names. Paste with variable names. So, ayan. So, ayan na yung ating data. And then, we save. Demo data din. Naka-SPSS lang. Demo data. And then, we analyze the Cronbach's alpha. So, sa Cronbach's alpha, we actually click analyze, and then we go to scale, and then we go to reliability analysis. And then, we copy all, Control A, the items, and then we move it to the other side of the box, and then we compute. There are so many reliability indices here. We have the parallel, we have the split half, and all of these are for internal consistency. But the most robust is the alpha. And then we check the different statistics. Actually, yung gusto ko lang talagang makita rito that is very important is the scale if item is deleted. Ibig sabihin, ano ang magiging kabuoang reliability nung 10 item na test kapag itong item na ito ay i-delete. So, ibig sabihin, pag tumaas pa siya, so tanggalin na lang siya. Pag tataas para tumaas lang yung reliability ng test. And then we click OK. So, ito ang ating makikita. Yung una ay case processing lang. Ibig sabihin, ano lang siya, parang descriptive lang. Pero ito talaga yung ating tinitingnan. Ayan, the Cronbach's alpha is 0.636. And for a classroom-made or a teacher-made test, mababa siya kasi 0.6 lang. Dapat ay 0.7 pataas. Pag mga standardized nga, dapat ay nasa 0.4. So that's 0.636. Pero let's take a look at this part. The Cronbach's alpha if the item is deleted. So, itong item number 5. Itong item number 5, 0.645. At saka itong item number 1, 0.645. Ibig sabihin kapag tinanggal natin itong item 1 at saka item 5 or item 1, okay, kapag iraran ulit natin, magiging 0.645 na yung Cronbach's alpha. Or kapag ang gusto nating tanggalin ay yung item 5 at i-run ulit natin, so magiging 0.645 yung ating Cronbach's alpha. Kaya naman yan mababa yung 0.636 kasi yung Cronbach's alpha affected naman siya ng number of items at saka number of respondents. So, take na yan, 0.636. That is our reliability coefficient. Then, we go back to our data in Excel. Okay, 0.636 is our alpha. Okay, so that's 0.636. Okay, dahil alam na rin naman natin ang ating Cronbach's alpha, so let us compute now for the standard error of the measurement. Ang standard error ng measurement natin is equal to the standard deviation times the square root of 1 minus the reliability coefficient or the Cronbach's alpha. So we have standard deviation times the square root of 1 minus the reliability coefficient. So our standard error of measurement is 1.36. So the observable score or the X could range from the true score, which is equal to the mean 5.02, okay, plus minus, so i-plus minus natin siya, okay, insert, plus minus 1.36, layo, yan. So that is our X. So that would mean a low boundary and a high boundary to make a confidence interval that the true score lies between the low boundary or to high boundary or the score of the student. So for the low, we have 5.02 minus 1.36, and then for high, we have 5.02 plus 1.36. So that's it. So ayan na yung essence ng ating classical test theory. which is the observable score is equal to the true score plus the error score. So it gives us a confidence interval that the actual score of the student, because there are some errors, really is not absolute 5.02, but it is somewhere between 3.66 to 6.38. So I hope you learned from that.